Wow.
Because we got the same numbers.
We can't see. No. Kidding me? Make sure you saw at least 4. Like at most. Before, or after.
Oh, yeah. Somebody though. It was a cool discussion. Teacher wrote out a whole scenario. Like you're working on this joint investigative team. What's the problem? What can you do about it? This is kind of interesting. I actually here's one guy. Well, you can't really do
Alright, quiet please. So, the wording is like the part that screws people up the most. So, there's like exactly 4, which is before. There's at least 4, which is 4 or more. There's more than 4. If it was more than 4, would you count the 4? Not. There's at most 4. If it was at most 4, what would you be looking for? 4 and lower. There's less than 4, which is actually like 3 or lower, right? Yeah, so just be really careful about it. It's really easy to screw those up. So at least 4 means 4 or more. There's only 5 days, so it's not like 4 forever. It's just 4 until 5. So for 4, it'd be 5, n is 5. We want 4 successes. The probability of success is 0.75. We want that to happen 4 times. These two numbers will always be the same. The probability of failure is 0.25. We want that to happen once. What's true about these two numbers? Add up to 1. What's true about these two? Look at this color coordination. Add up to n, right? So that's your first one. And then I also want to check, since at least 5, so at least 4, so I need 4 or 5. So 0.75 to the 5th. Again, these two are always going to be the same because that's the number of successes. Like I could do the rest of the formula just based on this without even looking at the problem anymore, because these two have to add up to 1, and these two have to add up to 5. I didn't get my answers, but I think everyone does like 0.633. Is that good? Questions on, like, should I go through and type it in or anything? Are we good then? Okay. Alright, let's look at the well, here, let's do this while we have it up here. Go to your calculator. No, we'll do it in a second. I want to be able to show you. the name of the board of shame. Okay. So these are binomial probabilities or distributions. And I'm going to go through how to do it with a calculator. So you got to know two ways. Like one is like, can you type out the formula, or write out the formula like we did yesterday and on that warm up. But also, do you know how to do the calculator, which is a lot faster. But you don't have to do it that way. So if something's going to qualify to be a binomial distribution, there's four things that have to happen. One is there has to be a clear yes or no, or you can look at it as like a clear success or failure. So like, did Maui show up to school or not? Yes or no? Clearly did, or you clearly didn't. Like, did you make the free throw or not? Did you flip the coin and get tails or not? It's not like you can kind of get tails. They have to be independent events. So one outcome doesn't influence the next. So like if I flip a coin, does what I get on that coin flip impact the next coin flip? It does not. Like the coin doesn't remember. If I roll a die again, it's not like the die is like changed because of what it got on the previous roll. Like they're independent, they have nothing to do with each other. Maui being absent is probably not independent. If he's sick one day, there's probably more of a chance he'll be sick the next day too. You know what I'm saying? So it's really probably not independent. But it's a fun example. There has to be a fixed probability. So you're repeating like the same event every time. So if it was somehow like Maui, is it okay if I just keep using your? You don't mind? Okay. Like if he like doesn't show up on Fridays half the time, but he's here every Wednesday, that's not a fixed probability. So I wouldn't be able to use it in that situation. And then the last one is a fixed n, which is a fixed number of tries. Okay. So we're gonna do binomial PDF today. I think binomial CDF tomorrow. So binomial PDF in your calculator. If you go to it, so go where you would find like normal CDF. So second bars, which gets you the distributions. And then you scroll, like I usually scroll up because it's toward the bottom, so that like flips you to the bottom. And you want, so there's binomial PDF and CDF. We want PDF. So we're going to do specific numbers. That's how I think of it. PDF is specific. A little weird there, but. So some of you it'll come up with this, and some of you it won't. That's okay. I can show both. But what you're going to put in, so like let's do Maui. We're going to do at least 4. We're going to do this twice. But there were 5 trials. If you don't have this, you just put 5 and then a comma. Like you don't have the menu, just put 5 and then a comma. What was the probability of success? 0.75. And then X value is how many successes are we looking for. So let's do 4 first, then we'll do 5 after. And then if I paste it, so that's what it would look like if you didn't have the menu, you just type it. And we'll like practice the order. So it's the N and then P and then the K or X value. So that will tell us 0.3955, which if you guys had the work from the last one on your desk, that was what you got for the 4, right? 0.3955. Then if we do it again, so I can put plus, and then go back to distributions, go to binomial PDF, specifically, specific number, really we should start with S. And then I can keep those the same, but I already did 4, so what do I have to change here? I gotta make this a 5. Say wait. Not too late. No, I'll go back. Let me do this, then I'll go back. So there's, that gives it away. You could have also done them separately and added them together. I just did answer plus, so it takes like my previous answer. Are you good? Okay. So, if I go back to my notes here, this is the order you're putting them in. So if you're doing it's the same for like both binomial parts. So you're going NPK. So if you remember NPK, this is so dumb, but like 5 years ago, I was like, just you guys should come up with like a phrase to remember it. And someone said California Pizza Kitchen, which isn't, but it like I've always remembered it because it's like so dumb it makes it work in my brain. Like California Pizza, I don't know. You gotta remember NPK. So whatever you want to, whatever phrase you want to come up with in your head to do that, do that. Somehow California Pizza Kitchen works. Like everyone in the class did it that year. I don't know. It's like a funny way to remember it, but whatever you can think of to remember it, that's what you're gonna do. So let's just do another example. And we'll go through the calculator again. Let's say 60% free throw shooter. Shoot 8. Find probability that X equals 5. So before we do it, is there a clear yes or no success or failure? I'm either going to make the free throw or I'm not, right? Are they independent events? Kind of arguable, but let's just say they are. If I make one free throw, I might be a little more likely to make the next one. Maybe I'm confident or something, but let's just assume there. Is there a fixed probability? Again, it's kind of arguable, but I would claim that there is. And then is there a fixed number of trials? Yeah, what's that? 8, right? So you want to remember NPK. So if you want to just, like some people on the side, just go NPK, write it down. N is 8, P is 0.6, and K is 5. And then what you're going to type into your calculator is binomial PDF in that order. NPK. Anybody got any funny ways to remember it? You would be willing to share? Okay, cool. Yeah, you got one? I got so excited. You're thumbing it down. So second distribution, binomial PDF. This one was 8 trials, 60%, 5 successes. If you have the menu, great. If you don't, you can just jump right to this and put it in order. So I get 0.279-ish. You guys got the same thing? Come on, come look at their calculator. Something's not working. We good? Or you say no, don't come look. Gotcha. Yeah. Come look. I don't know that. Well, alright, go to number one. Try number one. So some of these are kind of arguable. It's actually like a super controversial thing in sports. Like if a 70% free throw shooter makes 3 in a row, are they more than 70% likely to make the next one or not? There's been a ton of studies on that. Some people say yes, some people say no. But we're saying assume the above conditions are met for each of the following problems. So let's assume they're all independent, same probability, all that stuff. So try number one then. Got 4 people in here wearing shorts. You know what the wind chill was this morning? -8. I think the cutoff for no school is -10. Is it? That makes me feel a little better, actually. So 20 is the cutoff? Oh, really? Did you wear that outside, though? Trent, shorts outside? But you guys didn't? You just have them on. Right, did you wear shorts into the school? They're weak. They're soft. Yeah, the calculator is like a cheat code.
Well, yesterday, like, I was just, I don't know, I had one
Never punch kids. I like that. That is a good one. Never punch kids. That too. Never punch kids, Monica. Never. It's not SPK. Sometimes punch kids. Never. So keep in mind that you are on the test going to have to know how to do this both ways. So don't forget that you could do it this way as well. Yep. Yep. Yeah, it doesn't just disappear because the day changed.
I agree.
0.3087? Those you guys got? So it might be a good idea as you're doing the worksheet to write it both ways. Because you're going to have to do it on the test. I'd say most of the test is like, just give me the answer. But there's going to be probably 5 questions where I'm like, okay, write it out. Questions on one? Try to? Again, I don't think it'd be a bad idea to write out the actual formula there too. So, I think you just fired up.
Perhaps always fired up.
I think it's angry. It's scary. 2 okay? You good, bud? Alright, so we're not going to do all of these because PDF is not. Let's just start with number 3. We're not going to do CDF yet, but that makes a lot of these easier. I'm not worry about it quite yet. Go ahead and try 3. You can do 3. That's such a good one. Yeah, you never charted. That's good. You can put 0.03. I'm just putting the full answer. I don't know, so you can see like what the calculator said. So whether you write it out or not is up to you. Just keep in mind you're going to have to on the test a couple times. So what's up?
How did you round that? Like what?
I didn't round it. Oh, did you not see that at least 4?
Yeah.
That's what's good. Yeah, that's the tough part. It's gonna get you. You know what's super helpful? Reading the question.
I did read the
Read.
I do read the
Just-
questions.
I just kind of like looked at it over.
So did you read the question?
Yes.
Then?
Bro, I just put it in my calculator. I keep getting 0.
So it should be like 5, comma 0.3, comma 4 plus. Make more of it. You haven't started in your time. Yeah, I got it. Yeah. And that's the plus. Okay. Yeah. Seriously, I love those 2. Yeah. Good. We have that. So do the next one. We're not doing CDF today. You're not ready for that smoke yet. It's cumulative, so it does K and everything below it. You gotta crawl before you can walk. Calm down. Read the question carefully. It says coin, but it's not a 50-50 coin. It says at least. Ever? Bold statement. Never punch kids. Who said that? Who came up with that? Never punch crap.
I don't think you could punch crap.
I definitely wouldn't recommend it.
Probably like catch and punch them.
Seriously. Like eat you. instruction way, not like a calories way.
That's Ross is MyFitnessPal calories.
Yeah, he wouldn't eat that many calories in a day. So you can try 5, but I want to talk through. There's like an easier way. I don't know. There's a shortcut that's a little harder. And an easier way that's probably tougher to understand. So how you do it is up to you. Are we good with 3 and 4? All right. So for 5, we want the probability to be breakfast at least once. So n is 5. P is 0.8. At least once. So if I go 5 days, what are the possible number of times I could eat breakfast? 0 through 5, right? It could be 0, 1, 2, 3, 4, and 5. Those are my options. I want to find, so at least once means what? 1 or more, right? So I want to find that. So the like pain in the butt, but you don't have to think quite as much way, is do PDF of 1, PDF with 2, PDF with 3, PDF with 4, PDF with 5, and add them all up. There's nothing wrong with that. It's just going to take you a long time. The kind of like shortcut, but a little harder to understand way is what do all of these add up to? They have to add up to 1. So if I find this one, what can I do? I can subtract it from 1. So if I find this, since all of these have to add up to 100%, if I find this, like let's say that's 0.2. I don't know what it is. But let's say that's 0.2. Doesn't this big box have to be 0.8? So I can get to it that way. Or, if that doesn't make sense to you, you can just do PDF, 5, 0.8, 1 plus PDF 5, 0.8, 2 plus PDF 5, 0.8, 3, and just roll through them. So it kind of is up to you how you do that. What I would like you to understand, I mean you don't have to, but I would like to do it this way because it's the shortest way. Where I'm finding the probability I get 0 successes. Like what's the probability I never eat breakfast? And then if you subtract that from 1, like what's the opposite of never having done something? How many people in here have never bungee jumped? How many people in here have bungeed up at least once? Have you really? That's cool. Was it terrifying? Fun? What? Both? Both? But aren't those 2 things that I just asked like opposites? You're either in one group or the other, right? So the opposite of at least once is never. I got really, really close to 1. So that might be a good spot to write this too. The opposite of at least once is, if you haven't done something at least once, how many times have you done it? None. So by opposites, I mean they add up to 1. It's really called complements. And there's nothing wrong with if you just want to grind through and do PDF of those 5 different options and just add them up. I'll warn you that sometimes it's like there's 10 by the probability of at least once, and then you'd be going 1, 2, 3. It's up to you. It's gonna be a little longer. So let's have you do 6, 7, 8, 9, 10. Try them out, and I'll put the answers up and see what we do. Well, let's do 6 together. Well, there's at least 2. So I got 6 cars. What are my possible? Hi, Mr. Shin. Just gonna stop by every day.
Every day now. Hey.
So it's possible that 0 of them look I'm looking for at least 2. So if I were to put a box around what I'm looking for, it's those, right? So you got 2 options. Find these 2, and then add them together, and do what with that number? Drag it from 1. Or find these 5 and add them together. You can do it either way. Does that make sense, like what I'm talking about there? Okay. So I'll let you go through the rest. I'll freeze this. There's the answers for 6, 7, 8. Obviously do them first before you look. Then I'll put the answers to 9 and 10 up here, and then I'll walk around